Chapter 6, Section 7 for Mac 1105 College Algebra. This deals with financial models, so it's going to deal with specific equations in the financial world. A big concept in the financial world is principal, which is the amount you either borrow or the amount that you have in a savings or CD, something like that. Another concept is the rate of interest. Do not forget that interest, you have to convert it to a decimal. So if it says 3% interest, it's actually 0.03. First formula I have, shouldn't be new to you. It's a simple interest formula where I equals interest, P is principal, R is rate, T is time. Make sure you understand that T for a lot of these, most of these formulas, T is in terms of years. Okay. There's also, when you get into the compound interest formula, there's 5 particular ways they compound interest. They can compound it annually, which means once a year, so it's 1. Semi-annually, which means twice a year, which means 2 times a year. Quarterly, which means 4 times a year. Monthly, which means 12 times a year. Daily, which means 365. And these are the only 5 values that you can use for N in the compound interest formula. Here's an example problem. It says a credit union pays interest at 2% per annum compounded quarterly on a certain savings plan. If $1,000 is deposited into the plan and the interest is left to accumulate, meaning they're not taking anything out, how much is the account have after 1 year? Well, using the simple interest formula, we're going to plug 1,000 in for P, 0.02 for R, because it's 2% interest, 1/4, because it said quarterly. So we're looking at 1/4 a year. And we can see that we gain $5. So that's after the first quarter. You got to understand that the first quarter in terms of years is January, February, March. So then we add that $5 to the 1,000 and we compute it again using the same numbers. Only difference is our principal is no longer 1,000, it's 1,005 because we gained $5 interest in that first quarter. This quarter here represents the second quarter, which is actually April, May, June. We do the math, we get $5.03. Now what we're going to do is take that $5.03 and add it to the 1,005. Now we're going to go to the third quarter. So now we have 1,010.3 times the same numbers, 2% here. We gain $5.05 interest, $5.05. And that's from July, August, and September. We then add that to the 1,010.3, we get 1,015.8. Do the math again, we get 5,008. We find out when we add this $5.08 to the 1,015.8, we get $1,020.16. Make sure you understand that when it talks about quarterly, you have that first quarter, second quarter, third quarter, fourth quarter. They contain months. Then we come down here to the compound interest formula. And in here, the A represents the amount you have in the account. See, in the simple interest formula, the math calculates the interest. And then what we had to do is take that interest and add it back to the principal to find out how much we had in the account. For the compound interest formula, this isn't what happens. It automatically calculates the amount. And what we'd have to do is if we wanted to find out how much interest we made, we'd have to take the principal and subtract from A, and that would give us our interest. Make sure you understand that N in this formula represents how many times a year you compound it. So remember, annually is 1, semi-annually 2, quarterly 4, monthly 12, daily 365. Here's an example problem with this one. It says, invest $1,000 at an annual rate of 10% compounded annually, semi-annually, quarterly, monthly, and daily will yield the following accounts after 1 year. You can see here. that in terms of compound interest, the n becomes a 1. In terms of semi-annual compounding, the n becomes a 2, and we just do the math. Quarterly, the n becomes a 4, we just do the math. Monthly, the n becomes a 12, we do the math. And then daily, 365, we do the math. If you look at these values, here's how much we have in the account. If we compounded it annually, it's $1,100. Semi-annually, we get $2.50. Quarterly, $3.81. Monthly, $4.71. And then daily, $5.16. So you can see there's not a huge difference in the amount of money you gain. The difference becomes through how much money you have. The more money you have, the more you make. All right, this is the formula for continuous compounding. And it says the amount after t years, you take the principal times the e base. Remember, e is not a variable, it's a number, raised to the RT power. In other words, interest rate times time. There's a problem. It says the amount A that results from investing a principal of $1,000, so there's our P, at an annual rate of 10%, 0.1 is our rate, compounded continuously for a time T of 1 year. So 0.1 times 0.1 times 1 year. We do the math, we get our answer. See, most of these problems are dealing just with using the formulas. There's two more formulas. Effective rate of interest. The effective rate of interest, which is R sub E, of an investment earning an annual rent interest rate, R is given by. And really, these formulas deal with that base E, especially continuous compounding. It's a matter of just knowing the formulas and how to use them. Here's a problem. So suppose you want to buy a 5-year certificate deposit. You visit 3 banks to determine their CD rates. American Express offers 2.15% annual interest rate, compounded monthly, means 12 times a year. First Internet Bank offers you 2.2% compounded quarterly, means 4 times a year. Discover offers 2.12% compounded daily. Determine which bank is offering the best deal. And the bank that's offering the best deal, once you plug the numbers into the formula, is the one that's going to give you the best yield. Here, American Express ends up yielding 2.171%. First Internet Bank, 2.218. Discover, 2.143. So you can see that First Internet Bank is the best bank to invest because that's going to give us the most amount of money. And again, the only difference in the formulas is the interest rate and the n. Notice 1 plus, 1 plus, 1 plus, minus 1, minus 1. The interest rates have changed, and how they were compounded yearly changed. These are the present value formulas. It says the present value P of $8 to be received after T years, assuming a per annum interest rate compounded n times per year. If the interest rate is compounded continuously, there's the formula for the compounded continuously. And remember, all this formula is here is solving for P. So all we did was divide by E to the RT power. That's what the negative right up here represents. Remember, negative exponents mean they're fractions. Now here's an example problem. It says a zero coupon, meaning a non-interest bearing bond, can be redeemed in 10 years for $1,000. How much should you be willing to pay for it now if you want a return of 8% compounded monthly or 7% compounded continuous? So A, we're going to use that formula. Here's the amount we have. The A is the amount, 1,000. The R is we want 8% interest. It's being compounded 12 times a year, 10 years. Do the math. We should be willing to pay $450.52 if we want to have that bond worth $1,000 at the end of 10 years. Here's Part B, using the same thing, $1,000, putting the rate of interest in, but this is only compounded once. So we do the math, and 496.59.